Hello friends, today's question. A non-viscous liquid of constant density 1000 kg per meter cube flows in a streamline motion along a tube of variable cross-section. The tube is kept inclined to the vertical plane as shown in the figure. The area of cross-section of the tube at 2 points P and Q at height 2 meter and 5 meter respectively are 4 into 10 to the power minus 3 and 8 into 10 to the power minus 3 meter square. The velocity of the liquid at point P is 1 meter per second. Find the work done per unit volume by the pressure and the gravity forces as the fluid flows from point P and Q. So this is a tube having a variable cross section, and the height of point P, or we can say part of P, is given as 2 meter and height of point Q is given as 5 meter. So we have to find out the work done per unit volume by the pressure and the gravity forces as the fluid flows from P to Q. So direction of the fluid is from P to Q, and we assume that the area of cross section at point of this section P is AP, and the velocity of the liquid at this point is VP. Similarly, here area of cross section is AQ and velocity is VQ. Okay. So in this case, we are going to use Bernoulli's equation, and that is going to help to find out what will be our work done per unit volume by the pressure and the gravity forces. Okay, so let us start from the Bernoulli's equation. Bernoulli's equation gives us P plus half rho V square plus rho GH is constant. This is our Bernoulli's equation, and we are going to modify this Bernoulli's equation for the cross-section area P and for cross-section area Q. So you can say for point P, you can write this as pressure at point P plus half velocity at point P rho GH, and height of point P will be equal to the constant. Similarly, we can write for point Q also. For point Q, we have pressure for point Q plus half rho velocity for Q rho GH, and here we have Q, and that is equal to also constant. So from these two equations, let us call this as 1 and equation number 2. So you can say from equation 1 and 2, from equation 1 and 2, we get Bernoulli's equation for point P will be equal to Bernoulli's equation for point Q. So pressure for P plus half rho Vp square plus rho GHP will be equal to pressure for Q half rho Vq square plus rho GHQ. And we have to find out the work done per unit volume. So you can say the work done per unit volume, work done per unit volume, we make some adjustment in this equation. We get pressure at point P minus pressure at point Q will be equal to half rho we have here VQ square minus VP square, and we get here rho G, height of Q minus height of P. Now in this equation we have three parts. Okay. So you can say, and we are supposed to find out in the question work done per unit volume by the pressure and the gravity forces. So you can say that this first part, pressure of P minus pressure of Q, this will be our work done per unit volume by pressure forces. And second part is by the gravity forces. So you can say that our rho G HQ minus HP is equal to work done per unit volume by the gravity forces. So we are only required to find out these two. So let us first of all, okay, now in this question VQ is given to us. VQ is, sorry, not VQ is given, but VP is given. Velocity at point P is 1 meter per second. So we know VP, but we do not know VQ. So in order to find out this VQ, that is velocity at point Q, we are going to make use of the equation of the continuity equation. You can say equation of continuity, equation of continuity, which states that cross-sectional area of point P multiplied by velocity of point P will be equal to cross-sectional area of point Q and velocity of point Q. And in this case we are interested in velocity at Q. So Q will be equal to area of P, velocity of P divided by area of Q. So we substitute the values. We get velocity of Q, area of P is given as, area of P is given as 4 into 10 to the power minus 3. Velocity of P is given as 1, and area of Q is given as 8 into 10 to the power minus 3. This goes with this and it comes 2. So we can say that velocity of point Q is equal to 1.2, or we can write this as 0.5 meter per second. So we can find out now work done per unit by volume by the pressure forces, and which will be equal to nothing but calculation of this part. Okay. So therefore work done by pressure forces by pressure forces, let us call that W1. So W1, let us call it WP rather. Pressure is for P, looks much better. So you can say WP is equal to pressure of P minus pressure of Q, and that is equal to substituting all the values in this equation. So we have half rho VQ, we just found out, the rest of the values are given to us. This comes as half rho is our 1000, and velocity we found out as 0.5 whole square and minus 1 whole square plus 1000 multiply by G is supposed to taken as 9.8 and multiply by their height, that is 5 minus 2. So therefore we can say that our WP will be equal to, and if we solve it, this will be coming as minus 375 plus 29400, and this gives us 29025 joules per meter cube. So this is the work done by the pressure forces, that is 29025 joules per meter cube. And we are also going to find out what will be the work done by the gravity forces. Okay. We can say work done by the gravity forces, let us call that Wg, and this Wg will be equal to rho g, and we have a height of q minus height of p. Rho is taken as 1000, and we have 9.8, and here we have 5 minus 2, and this gives us that Wg, which we just calculated here also. This result is for this part, which is same as this part. So WP is about 29400 joules per meter cube. So this was our work done per unit volume by the pressure and the gravity forces as the liquid flows from P to Q. So this question was a little bit tricky in the sense we have to use Bernoulli's equation, and from Bernoulli's equation the information is given in the equation itself, okay, which we used to find out the work done by the pressure as well as by the gravity forces. Okay. So this completes the question. Thank you.